So today we'll discuss about the isometric projection. So till the last class, starting from your points, lines and planes, we have discussed orthographic projections. Okay, in the beginning classes we have discussed about this orthographic and isometric projections. So in orthographic projection, what is the principle that we have used? It is ortho, it is 90-degree projections. So all the projector lines from the corresponding points we are taking and towards the planes, it is exactly meeting at 90 degree or perpendicular. So that's why it is called orthographic projection. So we will go on to discuss isometric projection today, and all your orthographic projections, they are two-dimensional projections. So even though if we draw front view, top view and even side view, okay, that's what we have discussed. To get the complete the specification of any object, so front view, top view and including a side views are necessary to describe the entire object. For that, so we are going for the initial position, second, third position, including solid also we will discuss that. Okay, three minimum the projections will go for front view, top view and even a side view, and it is a two-dimensional projection. So isometric, how it is different from the orthographic projection in the sense, isometric projection, it is a three-dimensional projection. A single view, which is nothing but a three-dimensional view, which is drawn on the two-dimensional plane. It might be your computer screen or your drawing sheet or your sketchbook. Okay, a single isometric projection itself can give you the complete details about your the object. So here there is no front view, top view and side view, all those things. So we'll discuss that in detail. So let me give you the introduction. So what exactly the isometric projection? So isometric projection is a method for visually representing three-dimensional objects in two-dimensional plane in a technical and engineering drawing. It is an axonometric projection which the three coordinate axes appear equal and first and the angle between any two of them is 120 degree. That means iso means equal. So isometric projection, first we will discuss what is isometric and then we'll come back to the projection. Iso means equal, that's what I have given here, and metric projection means the projection which is not to the actual scale, which is drawn to the reduced scale. So this is called as the isometric projection. Iso means equal and metric projection is nothing but the projection which is drawn to the reduced size of the actual object. So that's what an isometric projection is, one type of pictorial projection in which all the three dimensions of the solid are not only shown in one view, also their dimension can be scaled from this particular drawing. So now you could able to differentiate orthographic and isometric projection. So let me take one example of cube. So I have taken a cube as the example here to explain this, what exactly this isometric projection. So this cube I have tilted little bit. For example, so let me take this as my cube. So assume that this is the cube. If I keep it on my hand like this, I place on any one of the plane, only I can see the straight lines in front view, or in top view I can look like it will look like a square, a cube. In the front view also it can look like a square if it is held like this, or if in this position if I hold like this, it look like a rectangle with this and this line will going to come. Correct? If I draw a line here, horizontal line, so what is the inclination that you're going to get on this edges? So because this cube, the adjacent edges, it is having 90 degree, correct? And if I draw a horizontal line like this, so what about the remaining, the angles on either side of your this end? It is equal inclination. That is, here 45 I'll going to get, and here 45 I'll going to get. The remaining 90 degree is the adjacent edge. So total 180 degree I'll going to get. So in case of isometric projection, to get the three-dimensional view of the object, I need to slightly tilt it like this. If I hold it like this, now we can see the complete three-dimensional view of the object. is it not? So earlier it was like this. So orthographic projection, we need to draw the front view, top view, and side view to get the entire the description of the object. Now in isometric projection, as I told, a single view can give you the complete details about the object. If I tilt it like this, so now the 3 dimensions you can see. So this is what I have shown here in this the cube. And if I draw, you can look at the cursor. If I draw a horizontal line like this here, correct? So why it is called isometric? Iso means similar. So that's what I've given the details in the introduction. 3 similar the angles I'll going to get between the 3 axes, that is x-axis, y-axis, and z-axis. So one of this edge of your the cube is one the axis. Here it is one axis, and in vertical direction it is one axis. So 3 similar axes means 360 by 3 means 120 each. The adjacent axis, the inclination, it is 120 degree each you will going to get. Now if I draw the horizontal line passing through this the intersection point like this, so this horizontal line represents the 180 degree, correct? And then here already 120 degree it is there after tilting it, correct? So remaining how much out of 180? Remaining 60 degree. So 60 degree by 2 means on either side. So here 30 degree I will be getting, here 30 degree I will be getting. So this is the only the basics that you have to learn. That means, so isometric projection is also called as the 30 degree projection, whereas the orthographic projection is called as the 90 degree projections. Here all the lines, okay, all the lines are drawn on the 30 degree line are the vertical projector line. That's what these are all the x, y, z. These 3 are called as the isometric axis. Here x, y, and z. So whatever the dimension, whatever the dimension that you have to take, and you have to draw the projection to complete the isometric projection, we need to draw on these 3 the axis only, either on the 30 degree lines like this on either side, or else on vertical line we have to draw the projection. So all of you understood this. So if I draw a horizontal line here, so 120 is there, total horizontal line it is 180. 180 minus 120, 60. 60 by 2 means on either side, here 30 degree, here 30 degree you are going to get like this. So here clearly I have given here so that you can easily understand here. So you can see here. So this, the dotted line which I have given, this, so this is the actual dimension or the actual length of the edges of your cube before tilting it. And it is 45 degree. How do you say it is 45 degree? Because adjacent the angle between the square or it is 90 degree, correct? If I take from the middle or the diagonal half of that 45 degree on either side, here 45 degree means here also I should get 45 degree. So the dotted line will give you the actual length, and this 45 degree will give you the actual inclination of your cube when the top cube is seen. And coming to this 30 degree which I have given in blue color, the lines which I have drawn here. So this is the isometric the projection. And why I have taken here 30 degree? Because isometric projection is also called as a 30 degree projection. And from this diagram we have seen that 120, 180 minus 120, 60, that means 30 on either side I will be going to get if I draw the horizontal line. So this is 30 degree. And the length you can see here, AD and AC. Okay, this AD is shorter than your AC. That is a reduced length than your AC, AD. That is, this is the apparent length of your the edge of your cube. This is the true length. AC is the true length and AD is the apparent length. So we need to calculate, okay, how much reduced the scale. So we have to take while drawing the isometric projection. Okay, so this diagram will help you, okay, how to take the isometric scale or the reduced scale. This all of you understood. That's the same cube I have taken here. The dotted line will give you the actual cube and actual length, and it is 45 degree. Why means the adjacent the side of the actual cube it is 90 degree, half of that if I draw from the diagonal, it is 45 degree. It is the actual length. AC is the actual length of your cube edge. And here AD, which are drawn here, and it is drawn 30 degree line. 30 degree line, this is the isometric, the angle where I have to draw the line. AD is the apparent length of your this cube edge. So whatever we draw in isometric projection, the true length we should not take. We have to take the apparent length or the reduced length of the actual length, and we need to draw it on the isometric axis, that is 30 degree line or vertical line. We will discuss that. We'll derive an equation that how much reduced length we have to take. Okay, so next the same this portion I will take this and I will redraw it, only this particular portion, because this becomes right angle triangle. Correct? ABC is one right angle triangle, ABD becomes one right angle triangle. Correct? So I'll take it in the next slide. See, ABC is one right angle triangle, ABD is one more right angle triangle, and AD inclination is 30 degree, where the isometric the length is taken, and AC, which is drawn on the 45 degree line, this is the actual length of your the object. So let me discuss here how to get the apparent length or the isometric length. These two triangles you can see, ABD is one right angle triangle and ABC is one more right angle triangle. Okay, so I'll take cos theta in both of this triangle. So cos 30 and cos 45. Cos 30 I'll take in ABD triangle, and cos 45 I'll take in ABC triangle. What is cos theta actually? Adjacent by hypotenuse, which is adjacent. Adjacent is AB, hypotenuse is AD for the ABD triangle. For ABC triangle, adjacent is AB and hypotenuse is AC. Correct? So if I take cos 45, so here I have written cos 45, adjacent is AB divided hypotenuse is AC. That is cos 45 AB by AC. What is cos 45? The general, the standard, the value of that 1 by root 2 I have taken here. Now we'll consider the triangle ABD. So cos 30 is adjacent by hypotenuse, that is AB divided by AD. It is cos 30. Cos 30, the standard value is root 3 by 2. Correct? So now, so I need to calculate what is the ratio in which, okay, I have to reduce the length with respect to actual length to the isometric length. So AC is the actual length and AD is the your isometric length. So that's what, so I am dividing this cos 45 by your cos 30. That is your the AB by AC. So that is your the actual cos 45. AB by AD is nothing but cos 30. So in this, so if you divide it automatically, root 1 by root 2 divided by root 3 by 2, you're going to get. So that is, if you simplify this, you're going to get AD by AC. AB will get cancels. AD by AC is equal to root 2 by root 3. So what is the value of root 2 by root 3? It is 0.816 something you'll get. 0.816. 6 is here, 0.816 the actual value. So what is AD actually? It is the isometric length AD, which is drawn on the 30 degree line. What is AC? It is the actual length which is drawn on the 45 degree line. Now, what is my intention here? I need to know how much the reduced amount of the dimension I should take while drawing the isometric projection. That's what. So AD is equal to 0.816 into AC. So what exactly you mean by this relation? So isometric length, whatever the length or dimension if you take in this chapter, so it is 0.816 times of the actual length that you have to take. For example, 30 millimeter is the actual length. Okay, 30 millimeter into 0.816, how much you're going to get? Almost 24.5 you may get. Okay, so 24.5 is the isometric length that you have to take while drawing your isometric drawing. So I think all of you understood this relation. Just it is an attempt. So simply I can take 0.816, you have to multiply. So this is the relation why we have to take 0.816 only, the ratio. So to get the isometric length. So in this the slide, I have given the difference between isometric view and isometric projection. So isometric projection, so here on rectangular, the prism I have taken into consideration. So isometric view and isometric projection. The isometric view is drawn to the scale without any reduced the dimension. Then it is called as the isometric view. Isometric projection in the sense it is drawn using the isometric scale dimension, that is always reduced dimension. Then it is called as the isometric projection. Next, how to draw the isometric scale. So here it is clearly given how to draw the isometric the scale. This entire diagram which you are saying, this is called as isometric scale diagram. First you draw one horizontal line. Draw an horizontal line, and from any left hand point you draw both 30-degree line as well as the 45-degree line like this to some length, and with the help of your scale, and this 45-degree line, that is an AD, you mark the dimension. For example, 5 millimeter, 10 millimeter, 20, 15 millimeter, 20 mil, like that you can mark it here for your reference. Okay. After that, for example, here 0, 1, 2, 3, 4, some example, so some marking I have done. How to convert that into the isometric, the length or isometric dimension? Just keep on draw the vertical line from the each and every dimension that you have marked, actual dimension on this 45-degree line, till it meets the 30-degree line. Now you can directly take with the help of your compass. This, if this is 5 millimeter means you take this isometric, the length that is 5 millimeter, and draw while drawing the isometric projection. Okay, so this is what, okay, you have to do it. So this is called as the isometric scale. If you have your calculator, directly you can multiply the actual dimension of the your any object into 0.816, directly you can convert it. But in industries and all, they use this isometric scale. So easily with the help of your compass, you can able to take the isometric length for each and every dimension. That's all. Okay, so I hope all of you understood this, how to draw this isometric the scale. Next, the question arises, how to draw the projection in the isometric projection. As I told, so how many axes we have in the isometric projection? 3 axes, x, y and z. So whatever we need to draw in isometric projection, on these 3, the axis only we need to draw. So whatever the entire dimension, 3 dimension of the object you want to draw in isometric projection, either I have to draw it on the 30-degree line, or else I have to draw it on the vertical line. So under any circumstances, you should not draw the dimension in any other the lines apart from these 3 axes of your the isometric projection. Okay, here just one example I have taken how to draw the cube. Okay, cube say around 50 millimeter length of the cube. So first what you have to do, first you draw the horizontal line always in isometric projection. Draw the horizontal line. On the horizontal line, you take any one of the point like this. You observe my cursor. I identify one point on the horizontal line, and from this point you draw the 30-degree line on either side. 30-degree line on either side. So after drawing the 30-degree line on either side, you take the isometric length of the your cube, that is 50 millimeter means around 41 or 42 millimeter you may get. With the help of your compass, you take the isometric length of the 50 millimeter. From here you cut this 30-degree line and you cut this 30-degree line. So after this, to draw the height of the cube, you draw vertical line from all these 3 points. You draw the vertical projector line. Once again on this vertical projector line, without changing that isometric length, whatever you have taken, you cut this from this point, you cut from this point, you cut this point, and from this point you cut this point. 3 more points you will be getting it. You join it with the, on all these lines, And then after that, what you can do it, from this point you can draw a 30-degree line in this direction, or else parallel to this line also you can draw anything to some length you can draw. And similarly from this point you can draw a parallel line to this line, or you can draw a 30-degree line in this direction. Okay, and wherever these two lines meets this intersection, you stop it and complete the lines, so that your cube is ready. Just one example I have given here. First, with this background, I hope all of you understood this basics. Only this is the basics which is required in the entire chapter to draw the isometric projection. That's all. So now in this class, around 3 to 4, the planes we'll discuss. We'll start from the beginning. We'll start from planes, how to draw the planes in the isometric projection. Starting from your rectangle will take, square will take, triangle one example will take, pentagon will take, and even hexagon will take, and even circular lamina also will take. The first one, the first example goes like this. You can see here. So I've given the question. Draw the isometric view of a square of 30 millimeter side in all planes of projection as given. Okay. So first you draw a square. What is a square? Where all the four sides are equal. I have drawn 30 millimeter square like this. This is the first, the actual, the square you have to draw it here to the scale, and you can name it 1, 2, 3, 4, A, B, C, D, anything you can name it. So after that, just now we have discussed the procedure how to draw the isometric projection. After drawing this square of 30 millimeter like this, you name it in whichever the fashion you want. So right side you draw one horizontal line. Just you observe my cursor. Draw one horizontal line. Identify any one of the point. I have identified this and draw 30-degree line on either side of this point. Draw a 30-degree line on either side of this point. So I will take any one of the point. I will call this as the A. So now on this 30-degree line, I will take the isometric length of this 30 millimeter. So isometric, either you can use isometric scale, you can draw that, or else 30 into 0.81 you can multiply. You may get 24.4 or 5. You may get it. You take whatever the value that you are taking with the help of compass. You take from this A as the center. You cut this 30-degree line this side, and also from the A as the center, you cut this 30-degree line on the other side also. And then you make this line thick line. And left side A to D you are getting is, mark this as the D. And the right side of the 30-degree line you are getting B. You mark it as the B. So how to complete the next the step of the projection from point D? So either you can draw a parallel line. Either you can draw a parallel line to AB. This is one method. Okay, or else we can draw a 30-degree line in this direction from point D to some length like this. Similarly, from point B, you can draw a parallel line to AD. One method, or else you can draw a 30-degree line from here, from D, in this direction. So wherever these two lines will meet or intersect, okay, stop here and erase the extension line and call that as the one more point, that is C. So join it with a thick line ABCD. The isometric projection of the square is done. So this is the procedure you have to follow to complete the isometric projection. Any exercise is given. Okay, I hope all of you understood this. So similarly, for the first one, I'll teach you all there are 3 different ways how we can different position how we can draw the isometric projection. Okay, so this is one method where 30-degree on either side we have to draw. Most of the 90% of the drawing is done with this method only. There are 2 more the method I'll teach you. So this is the other method. The second method, the same thing. You draw the true shape of your square which is given 30 millimeter, and you draw horizontal line similar to the previous example. Take any one of the point. I'll call that as the usual. Then one side, left side, you draw 30-degree line to some length, and then draw a vertical line. Draw a vertical line like this. Now you take the isometric 30 millimeter. You convert that, and you take isometric length of 30 millimeter from this as the center. you cut 30-degree line, and this as the center you cut vertical line, and call here this as the D, and from A to B this as the D. So till here it is same. Now after this, second, for the to complete this, from point D you draw a vertical line or else parallel to AB. You draw a vertical line like this from point D or parallel to AB, and from point B you draw parallel line to AD, draw parallel line to AD or 30-degree from B like this. See, draw vertical line like this parallel to AB, draw BC, that is the 30-degree line like this, or else parallel line to AD. So wherever these two intersections, okay, the lines intersect, that call that as the C. So your the square in the different position it is ready. Similarly, you take 30-degree right side and draw vertical line. One more you can get it. So let me show you that also. See, so your square is ready, 30 millimeter. You named it. Draw an horizontal line. You take any one point on this horizontal line. I'll call that as the A. Draw 30-degree line on the right side of you. Draw one vertical projector line. Now you take the isometric length of this 30 millimeter. Convert it. From A as the center, you cut this 30-degree line. From A as the center, you cut this vertical line. Once it cuts, call it AB and AD. You call it. Now, to get the C, from point D, you can draw a parallel line to AB or else 30-degree line from D, some length. And from point B, you draw a vertical line that is parallel to your either vertical line or else parallel to AD. So you're going to get like this. See, D, from point D, you can draw a parallel line to AB or 30-degree line. You can draw right side. Similarly, from B, you can draw a vertical line or else parallel to AD. So wherever these two lines intersect, you call that as the point C. So the one more position it is done. So let me put together all these views. Say A, B, C. The first one we have tried, that is figure C. Second one we tried figure B, and third one we drawn it is figure A. The same square the isometric projection can be drawn in either of these three ways, but in most of the cases we discuss, almost 95% we discuss the C, that is the first one, whatever we discussed, that we will see. That means why these three positions means one is the front view, one is inside view, so from the side how it looks, and one is from the top. So this will give you the three positions, but always we go with this particular method only. Okay. Similarly, so let me teach you for the triangle. So I've taken the triangle. So we're in almost triangle here, the dimension of the triangle. So you take this dimension as this AB dimension not given here. You take around 40 millimeter AB dimension, and then you draw 45-degree line and 60-degree line wherever it meets. So you're going to get a triangle. Okay, you construct the triangle, whatever, the equilateral triangle, isosceles triangle, any other triangle which is given, you construct the triangle to the scale first as usual. Okay, so now in this case, so triangle has got only three sides. Okay, so except your square or the rectangle, where we are going to get four sides, easily we can draw the isometric projection. Other than these three shapes, so we have to enclose it within the box. We will call this as the box method. Okay, we have to enclose whichever the object that you want to draw the isometric projection. We have to enclose within the rectangle or the square box. How to enclose this the triangle within the rectangular box? So your triangle is ready, A, B, and 1 given the name. After that, from A you draw a vertical projector like this, from B you draw a vertical projector like this, and then from point 1 you draw horizontal projector left side and horizontal projector right side. After drawing these projectors, so whatever the square you are getting it, erase all other lines and you retain the rectangle. So this is your outer rectangle of your triangle lamina. So you have to enclose in simple way how we can we have to enclose the triangle within the rectangle. So this is how we have to enclose it. So outer rectangle, I'll call it as ABCD. Okay, and then the triangle is AB and 1. This is the naming which I have given. For my convenience, you can give your own name. So first here for the triangle, what is the procedure in the sense? First, I need to draw the isometric projection for the outer rectangle. First, I'll draw the isometric projection. Next, I'll draw the isometric projection within that the triangular lamina. So just now 3-4 example we have discussed. So we know how to draw the isometric projection for the outer rectangle which is given. So you measure this AB and BC and keep it with you. So I don't know how much you're going to get. Okay, you measure it. So as usual, draw a horizontal line. Take any one of the point, and I'll call that as the point A, which I have named there, and draw 30-degree line on either side of your 30-degree line on either side of your the point A. To some length you can draw it. So afterward, A to B distance you take and convert that into isometric scale. A as the center, you cut it. Okay, cut this right side 30-degree line. Similarly, A to D distance you take and convert that into isometric scale. From point A, left side of your 30-degree line, you cut it. You call that as the D. So AD and AB is ready. How to get the C? For that, to get the C, so once again, no need to cut any dimension. So what you have to do? So from D, you have to draw the parallel line to AB, or else draw 30-degree line from D to some length. Similarly, from B, either you can draw a parallel line to AD, or else draw 30-degree line from B like this. Wherever these two lines intersect, you call that as the C. So now outer rectangle isometric projection is ready. So in the next step, so I'll teach you how to draw the triangle out inside this the rectangle. So AB, no, already the AB of your rectangle is same as that of the AB of your triangle, correct? So AB as usual it is there. How to get this point 1? So you take D to 1 distance or C to 1 distance, any distance you can take from this rectangle, and convert this distance into isometric distance. So whatever the dimension that you are taking, you have to take now onwards in isometric projection. So you need to take isometric scale dimension only, not the actual the dimension. Either D to 1 distance with the help of your compass you can take, or C to 1. Convert that into isometric length. If you are taking D to 1 distance, after converting isometric scale D to 1, this DC line you can cut it, call that as the 1. If you are taking C to 1 distance, convert that into isometric scale. From C, you cut this CD line and call that as the 1. Once you get the 1, immediately with the help of your scale and pencil, draw a thick line A, B and 1. You join it. All these 3 points, your triangle, the isometric position of the triangle is ready. So outer square you can erase it. Okay, this is the isometric projection of the triangular lamina. Similarly, if you draw it in the other two methods also, the vertical line and 30-degree right side, vertical line 30-degree left side. So you are going to get the isometric projection in this particular the way. So all the 3 given here. So you can try it. Okay, all the 3 shapes, easy for you to understand. So this is how we have to draw the isometric projection of your triangular lamina. So next we'll go to the rectangle. So rectangle, what is the difference between square and rectangle? So square where all the 4 sides are equal, rectangle opposite sides are equal. This is the only difference. Okay, so I have taken the rectangle of 50 millimeter by 30 millimeter. Longer side is 50, shorter side is 30. So I have named in my own fashion A, B, C, D. I have named it. I have drawn to the scale the rectangle left side. Now I need to draw the isometric projection of this rectangle. So just now we have discussed 2-3 examples. You draw the horizontal line right side. Take any one point. I will call that as the A. Draw 30-degree line on either side of your point A to some length. Now you take AD. If you want to draw AD, you take 50 millimeter and convert that into isometric scale. From this as the center, 50 millimeter means 40.1 you may get. Okay. From A as the center, left side 30-degree line, you cut it, call that as the D. Similarly, 30 millimeter length AB, you convert into isometric scale, you may get 24.5. From A as the center, you could cut the right side 30-degree line, so call that as the B, so you're going to get AB. Now, to get the C, from D, you draw a parallel line to AB, or else 30-degree line from D. Similarly, from B, you draw a parallel line to AD, or else 30-degree line, left side, like this. Wherever these two lines intersect, call that as the C, and join all these 4 points to the thick line. Your rectangular, rectangle in isometric position, it is ready in this method. So similarly, other two methods also you can try, you are going to get in this way. Vertical line 30-degree right side, so left side 30-degree vertical line, and the first method whatever we followed. So like this, all the three possible ways also we can try with the rectangle. So this how the rectangle is done. So next, so after rectangle we'll try pentagon also. So coming to the pentagon. So pentagon I have taken 30 millimeters side. Okay, for this you can draw the regular shape of the pentagon, its condition, corner condition, don't bother about it. You draw a regular pentagon. So 1, 2, 3, 4, 5. So each side is regular pentagon is all the 5 sides are equal. You take 30 millimeters as the length of the pentagon, the side of the pentagon. Okay, you draw the pentagon. You know how to construct the pentagon. You can construct the pentagon. So here also, so we need to go with the box method. That means, so pentagon has got 5 sides. So directly I cannot draw the isometric projection. I need to enclose this pentagon within a box. That is a rectangle or square, whatever it is. So how to draw the enclose the pentagon in a rectangular square? So 1, 2, 3, 4, 5 is your pentagon, correct? From 1 you draw horizontal projector left side to some length. From 2 you draw a horizontal projector right side, and then from 4 you draw a horizontal projector left side. From 4 you draw the horizontal projector right side. Okay. Now from 5 you draw the vertical projector upwards and vertical projector downwards. Wherever this vertical projector horizontal projector meets, you call it as the D. Here also vertical projector horizontal projector meets, it is, we call it as the A. Similarly, from point 3 you draw vertical projector like this. Wherever these two projectors meet, call it as the C. Similarly, you draw vertical projector downwards like this from 3, and this horizontal, wherever it meets, you call that as the B. So like this, so you have to enclose this pentagon within a box like this. I'll call the outer box as the ABCD. So easy for me to identify with the letters and numbers. That's why I've taken like this. So first, what is the procedure? First, I'll draw the isometric projection for the outer box which I have drawn to your hexagon. So as usual, I'll draw one horizontal line right side. I'll take any one of the point on that horizontal line. I'll call that as the A. And after drawing this box, you find out what is A to B with the help of your scale. You can measure this, and A to D also you can able to measure, and you have to convert that into isometric scale. First, after drawing a 30-degree on either side, A to B distance you take the square or the box and convert that into isometric scale or isometric dimension. A as the center, you cut this right side 30-degree line and call that as the B. Similarly, A to D distance you take, convert that into isometric dimension of the scale. From A as the center, you cut left side of the 30-degree line. You call this as the D. So after getting B and D, from D you can draw a parallel line to AB or else 30-degree line right side. Similarly, from B you can draw a parallel line to AD or else 30-degree line left side you can draw. Wherever these two lines meets, you call that intersection as the C. So the isometric position for the outer the box is ready. So now I need to identify this 1, 2, 3, 4 points within this the box, and I need to complete the isometric projection of the your pentagon lamina. Okay. So next step is, so already the triangular lamina we have discussed. In the same way we will do it. So you identify to get the 1 between AB, A to 1 distance you take and convert that into isometric scale. A to 1 you cut this AB line. Similarly, A to 2 or B to 2 you can take. A to 2 distance you can take and convert that into isometric scale. From A you can cut this AB line, you will going to get 1 and 2. Similarly, to get the 3, B to 3 distance you can take on BC line. From this as center you can cut, you will going to get 3. A to 5 and B to 3 distances are same. A to 5 distance from AD line you can cut this line, you will going to get 5. And D to 4, C to 4 distances are same. So you can take anyone the distance D to 4. From this D you can cut this DC line. I will be getting the 4 also. So after getting all the 5 points, you need to join this 1, 2, 3, 4, 5 points with a thick line. So once you join this all the 5 lines, you're going to get a pentagon. So your pentagon is ready. The isometric position of the pentagon lamina, outer square. Okay, later you can erase it. That is only okay. We have taken this box to draw the isometric position of the pentagon. So for this planes, let it retain, but retain in the sense the outer square should be thin line or light line. Okay, as much as possible, and only see the object is your pentagon. Object should be made thick. So this how we have to do the draw the isometric position of the pentagon lamina. Similarly, other two the cases also you can draw it. So you're going to get the pentagon lamina like this in other two cases also. And the last one is the pentagon lamina we're going to discuss today. So tomorrow class I'll teach you the circular lamina. The circular lamina isometric projection, if I tilt it like this, it look like an ellipse. So we have to draw the ellipse in the isometric projection for the circular lamina. I'll teach you tomorrow. So that one. So let me complete this hexagon the lamina. So draw the isometric projection of the hexagonal the lamina of 30 millimeter side. Okay, so you draw the hexagon of 30 millimeter, the circle method. The corner edge condition doesn't make any difference. You draw the regular hexagon of 30 millimeter side, and then here also you enclose the your hexagon within the box. So I'll call the hexagon all the 6 points of the 1, 2, 3, 4, 5 for my convenience. And how to draw the box for this? From 1 you draw horizontal projector, from 2 you draw horizontal projector, from 5 you draw horizontal projector left side, from 4 you draw horizontal projector right side. Similarly, from 3 you draw vertical projector and upward and vertical projector downward. Wherever these two vertical and horizontal projector meets, you call that as the C and D. Similarly, from point 6 you draw vertical projector upward and downward like this. Wherever this meets this horizontal projector of here you call this intersection as the A and this as the D. So outer box, let me call it as a ABCD. So easy for me to differentiate it. So after doing this this basic the requirement which is required to draw the isometric projection, preliminary things. So now you can start the isometric projection of the hexagon lamina. So first I'll draw the isometric projection for the outer box first. Later I'll draw the hexagon within that, because we are enclosing this hexagon within the box. So let me draw a horizontal line. I'll take any one the point and this. So I have taken this point as the B, or A also you can take. Okay, no problem. So just for a change, I have taken some other the point here. I'll take this as the point D, and I'll draw 30-degree line on either side, right side and left side. After this, before starting it, A to B and B to C distance you measure and keep it with you. So A to B distance you take and convert that into isometric scale. B as the center, you cut an arc on left side of 30-degree line. You call that as the point A. Similarly, B to C distance you take, convert that into isometric scale. From point B, right side 30-degree line you can cut, call that as the C. How to get the point D? From point A, you draw a parallel line to BC. or a 30-degree line. From point C, you draw a parallel line to AB or 30-degree line left side like this. Wherever these two lines meet, you call the intersection, call it as the point D. So this completes your the outer box isometric the projection. Now I need to get this inside hexagon points and I need to complete the isometric projection of the hexagon lamina. So for this, so ABCD is ready. Now you have to take your compass and you have to convert that distance. A to 1 distance between AB. You take and mark 1, convert that into isometric scale. A to 2, convert that into isometric scale and mark it. 1 to 2 is ready. So B to 3 distance you take, convert that into isometric scale, cut B and BC line, you're going to get 3. C to 4 distance you can take from C, and CD line you can cut it, you're going to get 4. C to 5 distance is take, convert that into isometric scale, and CD line you're going to get 5. 6, D to 6 distance you can take, convert that into isometric scale, cut on AD line. So you're going to get all the 6 points. Now you join all this 1, 2, 3, 4, 5, 6 line with a thick line. So this is so what you are required your the isometric projection of your hexagon the lamina. So outer box let it be as thin as possible. Only the inside the hexagon lamina is our object. So that isometric projection of that you have to make it a thick line like this. So you can see all the three positions also have given here. So today with this basics, so you practice all the 5 examples that we have discussed: the square, rectangle, triangle, and including pentagon, hexagon. In all the 3 positions, if it is required, you practice today. Okay, in your sketchbook or in your sheets. Okay, today itself. Any doubts you can okay. You can call me or you can send me a message, so I'll attend to it. And this PPT also I'll upload it today in Edge for your reference, so that you can refer this while drawing the isometric projection of the planes. Okay, I hope including the basics you understood today's class. So if any query is there, you can